We are skipping 2.5, so we're moving on to 2.6, families of functions. For the bell problem, you have to write this equation of a line through the slope of 3 and through the point of 1, 5. Again, plug it into your point slope form. Y minus y1 equals x, m, x minus x1. Once you plug it in, don't forget to distribute and get y by itself. And you should get y equals 3x plus 2. Like I said, we're moving on to 2.6, families of functions. We're going to be moving our graphs up and down, left and right. For the first one, our parent function, it's the simplest form in a set of functions that form a family. Transformation, each function in the family is a transformation of the parent function, meaning we're going to be moving it up, down, left, or right, shrinking it, stretching it. A translation is one of the transformations we can do. It shifts the graph horizontally, vertically, or both without changing the shape or orientation. A reflection flips the graph of a function across the line. So normally we're going to talk about our x and y axes. A vertical stretch multiplies all the y values of a function by the same factor greater than 1. So, for example, we would multiply everything by 3. A vertical compression, notice how it ends in ION, and it reduces all the values of y of a function by the same factor between 0 and 1, so a fraction, like 1/2, so fraction, FRACTION. Again, notice how compression and fraction both end in ION. So that will help you determine between stretch and compression. So our first one, our translation, again, we're moving horizontally or vertically. To move it vertically, notice how we're moving it up and down, and it is not grouped with our x. So we're moving if our original family function is this red one here, we would go up, or plus k, or down, minus k. A horizontal translation, meaning we're moving left and right. So again, our parent function is in red. If we move it to the right, notice how it's grouped with our x. It's in the parentheses. And notice how when we move to the right, it's negative. We take the opposite sign. And when we move to the left, it is positive inside our parentheses. So we have to determine how the functions are related if we have y equals x and y equals x minus 2. So to start off with, we have our table here. We have to determine our values. If we have x as negative 2, meaning we plug it into our original equation, so we plug in x for negative 2, which will give us y of negative 2. And the same thing for all. Since y equals x, these are all going to be the same. Okay, but then we're translating it. We have x minus 2, so we still plug in our x value of negative 2, and subtract 2, we get negative 4. Negative 1 minus 2 is negative 3. Hopefully we're noticing a pattern. 0 minus 2 is negative 2. 1 minus 2 is negative 1. And 2 minus 2 is 0. So let's take a look at this graph. I'm going to graph y equals x, so plotting these points, negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 2, 2. This is our parent function, y equals x, for our line. Should be a straight line. And that's the one in red. So this one is the red one. I'm going to do the other in, let's say, magenta. So we're going to plot our points. So x is negative 2, y is negative 4. We have 1, negative 3, 0, negative 2, 1, negative 1, and 2, 0. So again, this is this equation here. Connect your points together. And if you notice, going from our parent function to our transformation, notice how if we started at 0, we go down 2, down 2, down 2, down 2. If you notice, it is not grouped with our x, and since it is subtract, that means our relation, or how they are related, we went down 2. This will come in more helpful when we talk about parabolas. So our transformation, or how are they related, we went down 2. Okay, so again, we have our function. We got to find our values of x. So that means we plug in -2 into our original equation, x squared minus 1. So when we do that, whenever you square a negative number, remember it's positive. So then we subtract 1, we get 3. Again, plug in -1, we get 0. 0, we get -1. 1, we get 0. And 2, we get 3. So I'm going to go ahead and plot these points right now. So at -2, we're at 3. -1, we're at 0. 0, we're at -1. 1, we're at 0. And 2, we are at 3. Notice how it's a squared term. We will be talking about this more later on. But this is a parabola. It's a quadratic equation. So it will be in the shape of a U. Okay? And then it says we're translated up 5 units. So I'm going to do this in green. If we're going up 5 units, so if we start here, we're on the 0, we're going up 5, so we start at -1, 1, 2, 3, 4, 5, we'd be at 4. So at 0, we're at 4. Do the same thing for every point. Okay? Or, look at your original equation, y equals x squared minus 1. And since we're translating it up, that means we look at our term not grouped with x, which is -1, and we add 5 to it, so our x squared stays the same. And -1 plus 5 is +4. Put a +4. And then if we didn't know how to count on our graph, we could just plug in our values. -2 squared is 4. Plus 4, we get 8. And do the same thing. We'll get 5. We already did 4. And again, we get 5 here. And we get 8. So the only ones that will fit on our graph are the values at -1. So if we go to -1, we count up 5. 1, 2, 3, 4, 5. Oh, look at that. That's the right point. Do the same thing with 1. 1, 2, 3, 4, 5. Same thing. Our graph will look something like this. So our translation, obviously, that I told us we went up 5. This next one, we have to figure out how these two graphs are related. So again, if we plug in our points to fill out our graph, we would get 4, 1, 0, 1, and 4. And let's do black. We'll do 16, 9, 4, 1, and 0. Okay? Now, if we were to graph these graphs, we would notice, if you notice, it is grouped with our x here. So that means we're moving left and right. Since it is -2 inside our parentheses, our transformation, or how are they related, we went right to. So if you look at your x value of 0, we're at 0 and 4 for our two graphs. But if we move to the right 2, our same y values are the same. That is why we move to the right 2. There's your homework. We'll work on it in class tomorrow.